The next part of section 1.1 talks about the difference quotient. Now, the difference quotient is always given by this formula. This is a fixed formula, f of x plus h minus f of x all over h. So in the previous lesson, we learned how to find f of x plus h. So if this is your input, x plus h, then we are going to replace each x in the expression with whatever the input is. So we want to break this up into three different parts. Part one, we want to find out what is f of x plus h. So once again, my parentheses contains the input. So my input is x plus h, which means in that expression 2x plus 4, every time I see an x, whatever's in the parentheses, the x gets replaced with that input. So we're going to have 2 times x plus h, which is our input, plus 4. If I simplify this, I have 2x plus 2h plus 4. Okay, so that will be my f of x plus h. So that's part one. Second part, we want to find, well, what is f of x? That's the easy part. F of x is just equal to 2x plus 4. Okay, so we found f of x plus h. That's the first thing we needed. F of x was given to us. Now the third thing is we're going to put it all together in this formula. Okay, so what is f of x plus h? F of x plus h is equal to 2x plus 2h plus 4. And anytime you replace one thing with another, always use parentheses. So in parentheses, I have 2x plus 2h plus 4. This represents the f of x plus h, okay, because we calculated that. Minus f of x, so once again, use parentheses. F of x is 2x plus 4, and all that is divided by h. Okay, let's keep going. Let's simplify this. So now I'm going to get rid of the parentheses. I have 2x plus 2h plus 4. The negative distributes to the 2x and to the 4. So we have negative 2x, we have negative 4, and all of that is divided by h. So now if I add this, we got 2x minus 2x, that's 0. We have 4 minus 4, that's 0. And all I'm left with is this 2h. And we still have division by h. So we have 2h divided by h. These cancel, and you're left with just 2. And that 2 is called a difference quotient because we got that from this formula. Now this concept can be kind of tricky. We'll go over this again in class. So just kind of think about, where did I get the 2x plus 2h plus 4 from? Because in the formula, we always have to find f of x plus h. That is fixed. Anytime you see this this term, the difference quotient. F of x is just given to us. That's equal to 2x plus 4. And then in the third step, we just put it all together. Okay, but we will go over this in class, and then this example we will also go over in class. You're welcome to try it on your own. Remember, we want to do this in 3 steps. First, find out what is f of x plus h. Then write down what is f of x. That's the easy part. It's just going to be x squared minus 3. And then in part 3, put it all together using the difference quotient, which is f of x plus h. That's going to be from part 1 minus f of x. That's from part 2. And then all of that divided by h. But we will do this in class. Feel free to try it on your own. Okay, now another important concept which will come up over and over again is the concept of a domain. So the domain of a function contains all the values of x, which are the inputs, for which f of x is a real number. Remember our notation? We got f of x equals to y, where x is the input and y is the output. So here's one way to understand domain. The domain consists of all the x values, which when you plug in, you get an answer, basically. If it's undefined, if it doesn't exist, then that x is not in the domain. But if you get an answer, then that x is in a domain. So here's an example. Find the domain of f of x equals to x squared in interval notation. Now, interval notation, we will talk more about this in the support part of class. Okay, so don't worry about this too much right now. This we will cover in the support class. Okay, so we'll talk more about that later on. But right now, let's just focus on domain. The domain consists of all the values of x for which, when you plug them in, you get an answer. So let me just try some random numbers. Let's try like -4. If the input is -4, then my output is x squared, which is -4 squared. That's 16. If I get an answer, that means -4 is in my domain. So I can do this like many times. If I plug in 0, I get 0 squared, which is going to be 0. That's a number. That's a real number. So 0 is part of my domain. I can plug in decimals. That'll give me like 0.25 squared. I can plug in fractions. This will give me, like 3/4 to the second power. So basically, I can plug in anything, and any input will give me an output. So every single x value is in my domain because I always will get an output. So my domain is going to be all real numbers. Any real value of x when you plug in will give you an output. So our domain is all real numbers, and we'll talk about interval notation in class. Okay, now let's find the domain of f of x. So remember, the domain consists of all values of x for which when you plug in x, then the answer comes out to be a real number. So let me just try a couple of things. Let's plug in f of 0. So if x is 0, we're going to get, remember, x is our input, and our input is 0. Input is in whatever's in the parentheses. I get 0 plus 3 over 0 minus 2. So this is going to be 3 over -2. That's a real number. So 0 is good. It's part of my input. Now let's see what happens if I plug in 2. So I'm going to get 2 plus 3 divided by 2 minus 2. 2 plus 3 is 5. 2 minus 2 is 0. Now guess what? If we try to divide by 0, then our answer is going to be undefined. Okay, we can't have division by 0. If we divide by 0, our answer is undefined, which means that 2 is not in the domain of f of x equals to x plus 3 over x minus 2. Okay, because when you plug in 2, you don't get an answer that's a real number. So 2 is not in the domain of this. Let's keep that in mind. So the way we're going to write this is that our domain is going to consist of all values of x such that x is not equal to 2. Any other number of x will work, just 2 will not, because 2 is the only number that gives you a 0 denominator. Okay, let's take a look at another one. Let's find the domain of f of x equals to radical x minus 4. Now, if you remember square roots, if you have the square root of a negative number, that's not a real number. Okay, square roots can only be 0 or greater, like 0, 1, 2, 3, etc. So these are all real numbers, but if you have the square root of a negative number, these are not real numbers. So let me try something. Let me see what happens if I plug in x equals to 3. Then I'm going to get 3 minus 4, which is square root of -1. If my answer is a negative square root, that's not a real answer. So therefore, 3 is not in the domain of f of x. Let's try 4. If I plug in 4, I'm going to get 4 minus 4, which is 0. Radical 0 is 0, so that's a real number, which means 4 is in the domain, whereas 3 is not. So remember that whatever is inside the radical, whatever that expression is, this has to be 0 or greater. Because if that expression is negative, then we're going to have this kind of a case where it's not a real number. So the radical can only be 0 or greater. Okay, so an easy way to find the domain is you set the expression x minus 4. Remember that expression, it can only be 0 or greater. We set it greater than or equal to 0, which means x will be greater than or equal to 4. Okay, and then we will write this in interval notation. Because if x is 4 or greater, then you get 4 minus 4, which is 0, 5 minus 4, which is 1, 6 minus 4, which is 2, and all those are going to be real numbers. Whereas like 3 or anything less than 4 will give you a negative square root, and that will not be a real number. So to simplify, the domain of a function is usually all real numbers with the following two restrictions. Restriction number 1. If you have f of x equals to a over b where you have a fraction, remember that our denominator, it cannot be 0. If you divide by 0, it's undefined. So therefore, the restriction here is that the denominator b cannot equal to 0. Second restriction, if you have f of x equals to the square root of an expression, square roots cannot be negative. So therefore, whatever that expression is has to be greater than or equal to 0. Okay, these are our two restrictions. If you have a fraction, you know you have a restriction. If you have a radical, you know you have a restriction. Otherwise, at least for now, the domain will be all real numbers. So let's do these two in class. You can try them on your own. Think of these restrictions we have on the domain and try to do them by yourself, but we can go over them in class. The next one talks about sum, difference, product, and quotient of functions. So if you have f plus g of x, if you have this notation, that's just equal to f of x plus g of x. Same for subtraction, same for multiplication, same for division. So we have f of x equals 2x squared plus 5x minus 3, and g of x equals to x minus 4. Let's find these four things. Let's start with f plus g of x. So this equals to, by definition here, this equals to f of x plus g of x. Okay, so f of x, this is equal to 2x squared plus 5x minus 3. Make sure you always use parentheses. G of x is x minus 4. If we combine our like terms, we have a 2x squared. Then we have a 5x and a x. So 5x plus 1x, that's going to be 6x. And then we have a negative 3 plus negative 4, that's a negative 7. So f plus g of x equals to this, which means you're adding the two functions. F minus g of x, by definition here, is going to be f of x minus g of x. Okay, so let's, f of x, what is it equal to? It's equals to 2x squared plus 5x minus 3 minus g of x, which is x minus 4. Now, if you're adding two functions, you can just combine like terms. If you're subtracting, there's one extra step. And the extra step is that you write the first parentheses. You remove the first parentheses, just write the expression with the second parentheses that has a negative in the front, which is like kind of like an invisible 1. So the negative is going to distribute to both of these terms. So negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. If you combine our like terms, we get 2x squared. 5x minus x, there's like an invisible 1. 5x minus 1x is going to be 4x. And then negative 3 plus 4 is positive 1. So this expression is f of x minus g of x. Now, it also says find the domain in each case. We ask ourselves, do we have either of these two restrictions? Do we have a fraction? Or do you have a radical? If the answer is no, then the domain is going to be all real numbers. So in each of these cases, we don't have a fraction, we don't have a radical, so the domain is going to be all real numbers. Okay, let's do f times g of x. So f of x, so this is going to be, by definition, f of x times g of x. So f of x equals to 2x squared plus 5x minus 3, and g of x is going to be x minus 4. Okay, let's save this for class. Okay, we'll finish this off in class. The last one, we got f over g of x, so that's going to be f of x divided by g of x. So f of x is 2x squared plus 5x minus 3, and g of x is x minus 4. Right? So we can't simplify this any further. So that's our answer. But let's think about the domain. The domain has a restriction. If it's a fraction, the denominator cannot be 0, because if it was, we would have an undefined case. So in this case, our restriction is as follows. Our restriction is that x minus 4, the denominator cannot be 0, which means x cannot be 4 if you just add 4 to both sides. That's our restriction. So our domain is all the values of x such that x cannot equal to 4. And once again, we will talk about interval notation during class. Okay, we have one last example. We will do this one in class. So come prepared with questions, and I'll see you guys in class.